You have other bars going the other way, like every third spacing, you have a bar going. It just keeps them from moving left and right. They have to be pulled only on their length. There's no strength to them left and right. It's like a guitar string left and right. Okay, this video is too long. We're going to cut it off and start again. Bye. Have a good day. Okay, taking up from where we left off, you'll notice we went to a larger bar, and we're using a lot less of them. The strength of the bars is lower, but we're using more square inches because of that. And we ended up with 9 bars instead of 13. So that's a pretty good savings right in there. And what do we got down here? Oh, okay. Let's go on a field trip up here to something. What we have up here, I could change the dimensions on the drawing. Let's see. It's going to change on the ones we're going to actually look at. Forget that. You'll notice that, please. What is it doing? Oh, the drawing auto saves because I moved the screen. It wants to save it. Okay. You'll notice that every place there's a bar, these are the looking down through the column, the rebar wraps around it like a corner, sort of holds it in both directions. All these rebars are near a corner. Some of them are on a corner. Some are at an intersection, near a corner, sort of near a corner, at a corner. This stirrup is 3 separate pieces: the dark blue piece, the square-looking piece, and then the ones I don't know if it was me or the employees, we decided to call them the butterfly wings. Also, it looks like a really fat little airplane to me. So they're all in the same block. Okay. The outside black line, that's the shape of the column. And you'll notice there's a 2.5 inches deep, 7-inch wide notch cast into all of them. And that's why we have all these weird angles, is to keep the bar cover near the shape of the actual concrete. If this was a rectangular post, we would have, we'd have the outer rectangle, and then where these other ones where we'd have a square or rectangle surrounded them, so that they're still always around the rebar. If you have one that's got, say it had 3 3 across this end, 3 across the bottom end down here, down below where we're at, and then 3 on each side. Like it was this dark blue looking thing here. See if that square was the outside rebar, but you would have rebars halfway. It'd be 3, 3, 3, and 3. So 8 rebars on a column, commonly done in the Philippines. You would see that a lot. What you do to catch these ones that are on the mid span, you put a diamond-shaped rebar in there. Recommended practices for reinforced concrete instructions in the Philippines, published by the government, requires that diamond-shaped bar. And I have seen some expat builds that had them in there. I don't know who the architect was, but he either read the recommended practices, or he's a college graduate or whatever, or was well read. Another thing you'll see on the stirrups is that this stirrup starts here, goes around, and then bends again. We call these 135-degree corners. They don't just get to that last place and go straight down parallel to the other one. Same thing with this one. It went around, all the way around, come back, and this keeps the rebar from being stripped out of the concrete. This is also required. And I see about 10% of the builds in the Philippines have the 135-degree ends. But what we're here for Oh, we can make a little rest stop here. This black line here is a steel plate that we have on a. It bolts to the top of the work table, which is 2 4x8 sheets of plywood. We use it for everything. And the red things here, you see, you could if it was bigger. These red things are Schedule 82-inch pipe, and they're chosen because there's a minimum bend radius on rebars. Everything on rebar is in bar diameters. It's like 16 bar diameters or 27 bar diameters of lap when you join 2 bars end to end. You should offset them so that the two going away are exactly in line with each other. No, that's not done. It is done, but it's not done by me. I got enough problems, but that's the right way. Anyway, this is the minimum bend radius for a number 16 bar, 16 millimeter bar, or number five, or 16 millimeters, same thing. So it looks like our corners are big, but we're not bending them around a 3/4 inch bolt or something, which puts a much sharper bend. So we haven't, with this thing, we have not overstressed this towards ready to crack. We've never had a bar crack when we bent them. Some people do, but we have the right radius. We don't have a problem. There's bending plates for every shape we use. This thing just went off the screen. That's common beams that we use throughout the house. We only have about 4 sizes, I think. This is the upstairs column. We call it upstairs, or we call it it's closets. It's not really rooms. They're too small to be rooms. They're part of the ventilation system, but they look like rooms. And we put actual stairs up there, so some days we call it the second floor. But there's no rooms, and it's got a 26-foot hole across the middle of it that's open for ventilation. There's not really a lot of floor space you can walk on. But we have 10 columns. The black line is the shape of the column. The pipes are the pipes we bend this thing around. And this is made as 2 pieces, a left and a right. That's why we have 435 degrees, because there's 2 actual bars. This is this shape because this is cut out for an electrical sub panel. There's 10 electrical sub panels upstairs. We can hook any light in the house to any switch in the house. We can run a number 6 wire off any sub panel. If you wanted to put a large welding machine in the house while you're building it, just plug it in. Also, because there's a big hole across the middle of the house, we don't want to run wire all the way around to get to something on the other side. So what we do is we run a heavier wire to a sub panel. And that also gives you a lot more breakers. We have 175 light bulbs in this house, LEDs. Most of them are 6 watt. All of them can be powered by one 15 amp breaker and not even strain it. But we didn't want to have to buy all that wire and put the conduit in the concrete as we poured it for that many runs of conduit. And we don't, my personal preference, got nothing to do with legal or suggested or anything else. I don't use B caps, what do you call them? Wire caps, the little plastic things. Red is for the bigger size, and then you have yellows, and then oranges and blues for a smaller one. I just don't like to have those. I've had some trouble with people doing bad installations. So that thing we just looked at, it's got a shape like this, and you flip it over, it makes the other side. But what we came over here to look at, other than the field trip, I have a reputation for field trips this way. This is all the possible combinations of pipes that are on, I think we have 3 of these plates. But you have 2 sides to a plate. And that gives us 6 times the area of our plate to bend rebars on. And we have columns that are 32 by 35 inches. And all those rebars have been on these plates, so it takes up the whole plate. We're going to sneak over here to something I might want to use here in a minute. Okay, I've chosen an example column. Actually, this is a beam laid down flat with all the bars on the bottom and the top. That's what goes around the dirty kitchen outside. It's like a footer beam, and all the loads are on these two surfaces. It's used also for upper tie beams on first floor wall. This is only showing 23 quarters of an inch. The concrete is actually 24 inches. This little box here is drawn centered on this, but actually it's 24 inches. It's 1.5 bar diameters up here, just like it is there. But the form has got a 45-degree corner. It's a US 4x4 cut on a diagonal, and that raises up this this bar, and there's more concrete underneath it, of course, because you want to keep your 1.5 bar diameters. And that is not a problem in this case. Not before, that's this case. This is Villa Cecilia only, other than Texas Filipino, who has the same deal. I don't know other examples in the Philippines other than the R2 builds. He's currently showing his, when this was published, he's on his second floor and he's going for 3. I have a 7-inch concrete wall, poured concrete. This beam and that wall are cast at the same time. So it's solid concrete, 7 inches down here with 45-degree corners. But a 7-inch poured concrete wall. That makes this the top flange of a beam. The center of the center between the tension and compression loads is half of 10 foot 1 5/32 inches off the floor, whatever that is. So this is all in tension, and one of the bottom is all under compression. But anyway, I've chosen this for example because it's used 2 ways: laid down and stood up. The rebars for the stood up version are different, so we're gonna just assign rebars like we were doing the first design. And what I've done was I've changed the rebars. This is not the rebars we built with, but this is more representative of what your architect should have put in your drawings. It's sort of best practices. And this depth here, that could be anything, and the width could be anything. It's the number and where you put them on the stirrup. Notable things: 135-degree corners. We have 4 bars on the bottom. That's the tension side. We have 1 less. 4 minus 1 is 3 on the top. That's recommended practice. In Villa Cecilia, we have the same top and bottom because I have no bending loads on any of the beams. Not one beam in the house has bending load. In the dirty kitchen, they have bending load because there's it's a monolithic floor, it's about 5.5 inches thick, you know. So whatever it is, 1.5 inch cover, top and bottom. Anyway, this is a number of bars that's going to be restraining our tension load. We're going to assume it's upright and it's being pressed on at the top, and this is the tension side, and these are the compression side. So we need a number from the top surface to the center of the bars. That's this number. For calculating the volume of concrete in the beam, we need the actual width and the actual depth. Depth times width times length. That's your volume times 150 pounds per cubic foot. So we're gonna take that same what looks like a spreadsheet here and run through the calculations. 14 minutes. I tell you what, we're going to cut this off and call it part 2, because I don't think I'll finish reading this thing and explaining it in less than 15 minutes. So we're going to stop here, and then we're going to come back.